So our horizontal component, right, which is this, right, horizontal distance traveled from the starting point of the vector to the terminal point. All right, we want to find that, and we'll give it a name. Let's call it vector u here, this horizontal component. And then we got our vertical distance, how far we traveled up to get from the starting point to the terminal point of this vector. And that's our vertical component, right, our vertical distance, the length, right, of that vector there. So let's go ahead and resolve it into those two. Now, as we did a horizontal and vertical, right, we've got a 90-degree angle. So we've got a right triangle, which means we can involve right triangle trigonometry. Let's look at some right triangle trig and finding these components. So let's look at finding the horizontal component, u, here. So with that, u, right, is the adjacent, right, side to our 36-degree angle. So that implies we want to find the horizontal component. We want to find u, right? We can do what? We can involve cosine. So let's go ahead and do that. So as we involve cosine, right, that involves the adjacent side. So we got the cosine of 36 degrees equals the adjacent side, u, what we're looking for, divided by the hypotenuse, which is that force vector, right, 98 pounds, right, the side opposite 90-degree angle in our drawing. So then there's our definition of cosine, adjacent over hypotenuse. So as we solve for u, we find the horizontal component, right, we just got to go ahead and clear out the coefficient. So we'll go ahead and multiply both sides by 98. So we can get rid of the coefficient. As we do that, we end up with what? U equal to 98 times the cosine of 36 degrees. All right, so let's go ahead and look at that component. Now, if you want, we'll go to our calculator, and we can round it to the nearest pound, right, the nearest whole number for this component. So pull your calculator up. Let's go in here, make sure your mode is correct. And right now, see, I'm in radians. So we need to change that to degrees, since we've got cosine of 36 degrees. And let's type that in. So 98 times the cosine of 36 is equal to 79.3, right, or 79 pounds. So there's our horizontal component. So it's approximately 79.3 or 79 pounds. So there's our horizontal component, right? So again, resolving it into components, we found the horizontal component. There's HC. And now to find the vertical component, right? Let's go back to our drawing. Let's find V. So to find V, we can use what? Definition of sine. Right? Sine involves the opposite side. So sine of 36 degrees is equal to V, the opposite over the hypotenuse, which is the force vector of 98. And as we solve that, right, we can go ahead and multiply both sides by 98, right, to solve it. So again, keep in mind, where did we get that from? And we can write our definition back up here. Again, opposite over hypotenuse to find sine. So a little review with that. So as we're solving for V, right, V is equal to 98 times the sine of 36 degrees, right? And you'll put that in your calculator. So type that in, you get 57.6. All right, if you round it to the nearest tenth. So let's go to the nearest pound, nearest whole number. So 58 pounds, that's our vertical component for this force vector. So we resolve that into horizontal and vertical components. So our horizontal and vertical distance, right, on this right triangle, right, there's a length of those two legs, right, of that right triangle, which describe these components of the vector. All right, moving on, let's do another one involving components. Let's find the component form of the given vector. Now, vector is given as vector mn, so we got a starting or initial point of m and a terminal point at n. And they've given us those ordered pairs, so we can draw a picture of this directed line segment, this vector. Now, component form, let's keep in mind, what are they wanting us to find? They want us to resolve it into components, just like we did in the previous problem. And component form, we use our angular brackets. We have a horizontal component. We have our vertical component. So that's our component form. So let's go ahead and get a picture. So we're looking at vector mn. Right, let's go ahead and draw in our x and y axis. All right, and we got an initial point of 9, 15. So write 9 units. Up 15, somewhere up here in quad 1. Write 9 up 15. Right, finds our starting point. There's point M. And then write 12 units on the x-axis, up 7. Somewhere in here would be our terminal point. There's 12, 7. It's point N. So as we draw in this directed line segment, there's our vector. So now we want to resolve it into components. So let's look at our horizontal and vertical distance. Let's travel. So we can draw it in here in blue. So again, to see our components, right, we see the horizontal and vertical distance now with this. So here's our horizontal component. Here's our vertical component. Again, if you want, we can label it U and V. Give it names. So to find the horizontal component, right, let's go ahead and get the horizontal component, which is equal to U, right? What is that equal to? Well, we've got the x-coordinates, right, 9 and 12. So we've gone from 9 to 12 on the x-axis. So this change in the x-coordinates, right, will give us our horizontal component. 12 minus 9, right? So 3. So we've gone horizontal with this 3 units to the right. So there's our horizontal component, 3 units. All right, now our vertical component, which we've labeled V, is our vertical distance, which we can find by subtracting the y-coordinates. So again, we've gone from point M to N, so our y-coordinates, 15 and 7. So as we subtract those, what's 7 minus 15? Say negative 8. So there's our vertical component for this vector. So that implies our component form. Right? We can now write it out. So this vector Mn is given by the components of 3 and negative 8. Right? Write 3, down 8. So there's component form for this vector. All right, so that's a review of some vectors, all right, back from earlier in the semester. All right, let's move on. Let's take a look at problem number 19 as we get into our conic sections that we just did not long ago. And we're going to take a look at the different conics in the next few examples. So let's start with the parabola. So looking at the parabola, we're talking about characteristics of the equations of having one squared term, either x or y. So with a parabola, we're talking about a quadratic graph. Now in a quadratic function, where you have a U-shape or upside down U-shape, we're looking at the x squared term. Or if we have a quadratic that opens right or left, we're looking at the y squared term. So with that said, let's go ahead and write down the standard form. So it wants us to talk about the vertex, focus, and directrix, which defines our parabola. And our standard form is x minus h squared, right? Create the square with x, isolate the squared term, put your first degree variable, which will be y, on the right-hand side, and its coefficient, we're going to label 4 times p, 4p, times y minus some number k. And again, h and k reference our vertex. right? The vertex is that ordered pair, HK. And P will tell us about our focus and our directrix. All right, so keep that in mind. And if P is greater than 0, it opens up, right? And if P is negative, in this example, it opens down. So let's go ahead and look at this problem. And again, to find the focus, right, and the directrix, we're going to need the value of P. P is the distance we travel from the vertex to the focus and to the directrix. Now, directrix equation line, focus is a point that parabola focus is on. So let's go ahead and write this in standard form. That's going to be our first step. So we'll make a note. Rewrite in standard form. Now to do that, we want to go ahead and group the x terms. So we got x squared plus 6x. And we're going to move, I'm going to leave a little room to create my square. I'm going to move the y term and the constant over to the other side. So we'll subtract 8y and we'll subtract 1. Now with that said, we're now ready to create our square. So that's going to be our second step, to complete the square. So to do that, we're going to identify the value of b. Now make sure your coefficient of x squared is 1. If not, make it 1. So it's 1. So we look at completing the square, value of b is 6. So we're going to take half of that number. It's always half of b. So to create a square, we're going to have to add half of b squared into our equation. That means we're adding in 3 squared, or 9. Well, to be equal, we've got to apply the addition property of equality. And we got to add 3 squared to the other side of the equation to keep it equal. So now we've created a new quadratic trinomial that we can rewrite as a square. So that implies we have x plus half of b, x plus 3, right, squared. Yeah, if we square x plus 3, we're going to get x squared plus 6x plus 9 back. Equal to negative 8y, right, minus 1 plus 9. And if you want, let's go ahead and add these together. Right, so that's minus 1 plus 9, which is equal to 8. So we got a plus 8 here. Right, so again, just simplifying this down. Now I'm going to go ahead and take it a step further. I'm going to go ahead and rewrite x plus 3 with a minus sign, because when we look at the standard form, we talk about the number being subtracted from x or y in your squared term, right, as the x or y coordinates. So x minus h squared, here's h, right, negative 3 will be the x coordinate vertex. And then we want to make sure this coefficient here is 1. So we've got to go ahead and factor. So let's factor out that negative 8 and make it a 1. So as we do that, we're left with y, and we're left with a minus 1. It's negative 8 times y, negative 8y. Negative 8 times negative 1 is positive 8. So now we got our standard form equation right in front of us. So here again is x minus h squared equal to 4p times y minus k. So we're done. We've got our goal. So we've met our goal in this problem. So again, here's h, here's k, and here's the value of 4p. So to go to our characteristics, let's go ahead and write down our vertex, which is our key point in getting the sketch. And this is the ordered pair h and k. So the ordered pair would be negative 3 and 1. So vertex at negative 3, 1. And then our focus comes from the value of p. All right, so what did p equal? Well, we know what 4p equal. So keep in mind 4p equaled negative 8. So p equals negative 2. So if we solve for p, we get negative 2 here. All right, now what does that mean? That means our parabola opens down, and that means we're going to go down 2 units. from the vertex to get the focus. So our focus is going to be at the ordered pair of -3, -1, right? Down 2 from the vertex, right? So if you want, let's go ahead and sketch in what we're finding. Get a picture of our parabola and what we're talking about. So -3, 1, left 3, up 1. This is the vertex, which is actually the max point in this parabola. So we'll go ahead and plot that ordered pair. So there's the vertex. And it opens down, right? We had that -x² term, right? And this problem, if you to solve for y, or talking about standard form, the value of p, right, was negative. We knew it opened down. And to get the focal point, we go down 2 units. So down 2 units would be right here at -3, -1. So there's that distance. There's that p value of -2. Down 2 units. Now our directrix, all right, let's go ahead and write that in. What will our directrix be? Well, our directrix, we're going to have to go up 2 units to get to the directrix. So same distance to the focus as is to the directrix with any point on a parabola. So as we go up 2 units, we'll be up here at 3. I'll plot this point, -3, 3. And I'll graph the line, the horizontal line. The directrix is always perpendicular to the line of symmetry, which is the vertical line down the middle of the parabola, which is through the vertex, the line x equal -3. But y equal 3 would be our directrix. So up 2 from the vertex, up 2 from the point -3, 1, it's -3, 3. So the equation line passing through that point, right, is our directrix. So there's our information for this parabola. And it helps us again to see that information. So I like to graph it too. All right. So again, that's a review of our parabola. Let's move on. Go to problem number 20. And let's review the circle. Now the circle, right, we're looking at circle equation. We're dealing with 2 squared terms. Right? We're dealing with x and y being squared. And it's the sum of those 2 squared terms with coefficients of both 1, both being the same. You can reduce them to 1. So our standard form is x minus some number h squared plus y minus some number k squared equal to r squared, radius squared. Right? Where our center point, right, is our ordered pair h and k. And of course, r is referencing the radius, the distance from the center at any point in the circle. So the center and radius, we can graph our circle easily. So that's our work here, right? Our work is to rewrite, first step. We need to go ahead and rewrite this in standard form. So we can start to look at the characteristics that describe this graph, just like we did earlier with the parabola. So I'm going to go ahead and rearrange these terms, the x terms and the y terms, put those together, and then we'll work on creating the squares of both. I'll leave a little room. Remind myself I'm going to have to create a square with the x's. Got a plus y squared and a minus 12y. We'll put those together. And we need to go ahead and move that 72 over. So we're going to have a 9 minus 72 as we subtract that over to the right side of the equation. All right, well now we're ready to go with completing the square. So that's our next step. We got to complete the square with both x and y, right, in this example. So let's identify b and do that. So here's b. So b is equal to 12. Half of 12 is 6. So we've got to add in a 6 squared, and don't forget, where you add on one side, got the other side, keep it equal. And then here, again, make sure the coefficients of x squared and y squared are 1. Not make them both 1. In a circle, they're going to both be 1. Here we got b value of -12. And, of course, taking half of that, we get -6. So we're going to add in a -6 squared on both sides, right, in our circle. And now we can rewrite. So now we can get our squares with both. So now we got these new quadratic trinomials. So let's go ahead and write the squares. So we have x plus half of b. So x plus 6, right, squared. And yeah, if you square x plus 6, you're going to get x squared plus 12x plus 6 squared back. Right, you get x squared plus 12x plus 36. You would just square it out. And then plus, same thing here, we got y plus half of b. So y plus negative 6, right, squared. As we're writing our square here. And equal to, let's go ahead and reduce over here. So we got 9 minus 72. So I'm going to go ahead and subtract these, start to combine these terms. All right, plus 36 plus 36. All right. And with that said, I'm going to go ahead and rewrite with a minus. So x plus 6, I'm going to go ahead and put in standard form x minus negative 6. So there's your x coordinate for the center point, negative 6. X minus 8 squared. And of course, y plus negative 6, same as y minus 6. So 6 is going to be our y coordinate. There's our value k. And as we add these up, right, negative 63 plus 72, we get a 9. Right, so there's our standard form. So now we've got exactly what we're looking for. So here's the standard form circle. So we've got h, we've got k, and we've got r squared, right, in our example. So it's our standard form. So that implies what? So that implies our center point. So the center, which is equal to h and k, right? We get a negative 6 and a 6. So we're centered at negative 6, 6. And our radius, right? We know the right-hand side is r squared. So if r squared equal 9, we know our radius is 3. So we take the square root. So there's our radius, which is our distance from the center to that. And again, if you wanted to graph it, it wouldn't take long to get a quick sketch, right, of this circle. So we could graph it left 6, down 6. Here's the center. Actually, we got negative 6, 6, not negative 6, negative 6. So that'd be left 6, up 6. Right, as we graph in the center point. So let's go ahead and draw a picture of it while we have it. So left 6, up 6. Here's the center. And then doing a radius, we'll draw these in blue. So we go down 3 units. Right, we'd be here at this point, negative 6, 3. Right, there's the distance of 3 units. There's our radius. We go up 3 units, we'd be at the order pair negative 6, 9. If we went right 3 units, we'd be over here at the point negative 3, 6. And if we went left 3 units, we'd be over here at the point negative 9, 6. Right? And then we can draw in our circle. So there's a picture of our circle. Again, showing our radius, right, of 3 units. Left, right, up, and down, just some quick points to plot using the radius. So that's a good review of the center circle. All right, moving on. Let's go to the ellipse. Now, elliptical equation. We have the sum of 2 squared terms also. Except now, comparing that to a circle, all right, we don't have coefficients that are both 1. So standard form, we have a x squared term, just like we have with the circle, and we have a y squared term, and it's the sum of 2 squared terms, just like the circle. Except now we introduce coefficients. We call 1 over a squared or b squared. Right? And again, these can change depending on how the ellipse is stretched out. When I say stretched out, ellipse looks like a circle stretched out horizontally or vertically. And in standard form, we set it equal to 1. So again, in an ellipse, right, we're looking at, standard form there, sum of two squared terms, but coefficients that are no longer both 1, like they are in a circle. Now, how to identify A or B, we want to remember that A is always larger than B in an ellipse. So if A is with X, like I've got it written here, it'll be an ellipse that's stretched out horizontally, what we call our major axis being horizontal. Or if A ends up being Y, it's going to be stretched out vertically, which means our major axis can be vertical. So let's see what happens as we write this one in standard form. So that's our work. All right, let's go ahead and get the standard form equation. So to do that, we're going to have to create the squares of x and y. So we need to go ahead and group the x terms, 9x squared plus 72x together. Leave a little room, remind myself we are going to create a square. We have 25y squared plus 250y. So go ahead and put those together. And we need to go ahead and move the 544 over. So go ahead and subtract that. And then next step is we need to make these coefficients 1. So we need a factor to do that. So again, I want to make both of them 1 at the same time before we can create the square. So let's go ahead and factor out. So as we factor out the 9, right, we'll be left with x squared plus 8x. I'll leave a little room to write my square. And then I'm going to do the same thing with the y terms. We factor out the 25, I'll be left with y squared plus 10y. And leave a little room, equal to negative 544. Alright, so now I'm ready. Now I have the coefficients of 1 with x squared and y squared. So now let's complete the square. Alright, that's our next step. Let's complete the square with x and y. So identify b. So b is 8. So we're going to take half of that. So we're going to introduce 4. Now here's where you got to be careful. We factored out this 9. This 9 distributes to each term. So over here on the right hand side, we've got to do the exact same thing. We've got to add in 9 times 4 squared to keep it equal. And then here we got value b. B is 10. So I'm going to take half of that. So that's 5. And we're going to add in 5 squared here. And remember that 25 goes with it. So we got to add the exact same thing over here on the other side. 25 times 5 squared. Alright. So again, we're getting there. So I want to create our squares. Now we got these new quadratic trinomials. And we can write as a square. So that implies we got 9 times x plus half of b. So x plus 4, right, squared, plus 25 times y plus half of b, which again half of b is 5. So y plus 5 squared equal to, and I start to simplify over here on the right side. So we got negative 544, right, plus 9 times 4 squared, right, which is 9 times 16, or 144. So plus 144, plus 25 times 5 squared. 25 times 5 squared is 25 times 25, which will give you 625. So now we're close. Let's go ahead and write a minus sign and simplify those constants on the right hand side. So I got 9 times, I like to always look at the minus, that's x minus negative 4. What are you subtracting from x and y? You see your x and y coordinates for your center point. Plus 25 times y minus negative 5 squared. And then let's add these up. So what's negative 544 plus 144 plus 625? When you add those up, we get 225 total. So 225. So our last step, in order to get standard form, we must set it equal to 1. So we got to divide out that coefficient. So set it equal to 1 is our next step. And then reduce. Can you reduce these coefficients? Yes. 9 goes into 225 exactly 25 times. 9 times 25 is 225. 25 goes in 225 9 times. We reduce that to 1/9. And then here's our 1. So in the end, our standard form, we end up with x minus -4 squared over 25 plus y minus -5 squared over 9 equal to 1. And at this point, once you recognize a and b. So remember, a is always greater than b. So here's a squared, and this is an ellipse only. A is always greater than b. There's b squared. So you've got your standard form, right? At this point, we can stop. So we're good to go now. So we see the value of h, right? We can put that up here. There's h, there's k. We're looking at those x and y coordinates. And again, a squared is 25. So if you want, we can go ahead and find a, because we're going to need that here in a second. So a is equal to 5. Right? So we'll need that value. Now, let's go ahead and talk about these characteristics they ask for. So an ellipse, you got to find the center. You've got to find the vertices. And you got to find the foci. So the center is that ordered pair, h and k. So we got -4, -5 for the center. And then our vertices, in order to get the vertices, you need the value of a. So we know a is 5. Now here's where you got to know whether your major axis is horizontal or vertical. Since a is with x, right, that means we're going to go right and left 5 units. Right, left 5 units, right? And the reason for that is we have a major axis that's horizontal. A is with x. All right, so again, a is with x, right and left, a is with y, up and down. So what's right 5 units from -4, 5? Well, you'd add 5 to the x coordinate and you get 1. So one of our vertices is at 1, -5. And then what's the other vertex? What's left 5 of -4, 5? Subtract 5 from the x coordinate. We get -9, -5. There are your vertices. Adding and subtracting, right, left 5 from the center point. And then, to find our foci, we need the value of c. Now, how do you get c? In a ellipse, right, c squared always equals a squared minus b squared. So in this example, c squared is equal to 25 minus 9. So c squared is equal to 16, which means c equals 4. So c is 4 units. So we're going to move right and left 4 units. So as we do our foci, we won't write them in blue. So what's right and left 4 units? What's right 4 units from -4, -5? Add 4 to the x coordinate, and we get 0, -5. And if we go left 4 units, what's left 4 of -4? So -8. So you're adding and subtracting 4 to go right and left 4 from the x coordinate of the center. And those are your foci. So there's your center, there's your vertices, and there's your foci, right, for this ellipse. And if you want to graph it, you could easily graph it. Right? You can get a quick sketch if you want to see a picture of this graph. So just to show it over here graphically, we'll build in my x and y axis. If I go left 4 units, and I go down 5 units, right here's the center. -4, -5. So plotting in our vertices, we go right 5 units. We'd be over here at 1, -5. So there's that distance of A, 5 units. And we go left 5 units, we'll be at the other end. There's that point, -9, -5. All right, and that allows you to sketch it. So at that point, you can graph in this ellipse. So you're looking at this ellipse, there's a sketch. And the foci, which is the value of C. All right, you go left 4, right, and right 4. So you're looking at these points right here. There's 0, -5. And over here, there's -8, -5. So again, that value of C, 4 units. So just to sketch it, so again, you can take that information, right, and graph it. All right. Moving on, let's do the hyperbola. Find the center, the vertices, and the foci of the hyperbola. Now the hyperbola, a little different than the ellipse, not much though, but not with standard form. In the hyperbola graph, we've got the difference of squared terms. So as you talk about standard form, which I'll go ahead and write that over here. Our standard form for hyperbola, we've got our x minus h squared term and our y minus k squared term, right? Or we switch it up. We can have y minus k squared minus x minus h squared. We have one positive term, either x or y. In this problem, it's x. You can tell looking at the equation. And whatever the positive term is, we have a. Right? So a is with the positive term. So whatever's positive, not what the larger denominator is, like is an ellipse. And we set equal to 1. So it looks very similar to the ellipse. Of course, now we're subtracting, right, instead of adding the two squared terms. So that's what we want to do, right? Our first step, right? Rewrite it in standard form. So let's go ahead and do that. So we'll go ahead and rearrange the equation so we can set it up to get our squares. So we'll put my x terms together. 7x squared minus 70x. Leave a little room. Remind myself we are creating squares. Minus y squared plus 4y. And that 59, we'll go ahead and move that over. Subtract it to the other side. All right. And now let's identify, as we look at here in our problem, I'm going to go ahead and what? I'm going to look at factoring. So that's going to be my next step. I need both of these coefficients to be 1. So let's go ahead and factor those out so we can make these 1. So as I factor out the 7, right, so we need to factor. So I'm going to go ahead and do that. And I bring that out, I got x squared minus 10x. As I factor out the negative here, now remember you're factoring out of both terms, we're left with a y squared and a negative 4y equal to negative 59. So that's key. Make sure you're factoring out of both of these terms, right? Both the x terms and both the y terms, right? And now we can complete the square. So now we'll complete the square with both, right? And then we should be able to recognize h and k. So let's go ahead and identify the values of b. So looking at the values of b, so we got here a b value of negative 10. So we'll take half of that, so negative 5. So we'll add in a negative 5 squared. And over here we got a b value of negative 4. So we take half of that. We get negative 2. So we're going to add in a negative 2 squared. And just remember, we got to do the same thing on the other side. And don't forget about what you factored out. So that's 7 and that minus that we factored out and distributed with each of those terms. So over here on the right-hand side, let's go ahead and add in that 7 times negative 5 squared. And the minus negative 2 squared. Doing the same thing to both sides. And now we can write the squares with both, right, in order to get to our standard forms. So we end up with what? 7 times x plus half of b, x plus negative 5, right, squared. And then we got a minus. As we, again, write the square, y plus half of b, y plus negative 2. Right, all that being squared. Equal to negative 59. And we'll go ahead and start simplifying over here on the right-hand side. As we do that, what do we get? We get a 175. We got 7 times 25. So that's 175. Minus negative 2 squared, which is minus 4. Right? So again, let's simplify a little bit. We got 7 times x minus 5, right? X plus negative 5 is x minus 5. Minus y plus negative 2 is y minus 2. And that's equal to, as we add these up, negative 59 plus 175 minus 4, that adds up to 112. And now we're ready to set it equal to 1. Right? So we need to divide out that 112 on both sides. So let's go ahead and do that. And we'll have our standard form equation sitting in front of us, which will lead us to all the characteristics to our graph. So what do we end up with the standard form? Now do reduce your coefficients. Right? 7 divides into 112 16 times. 7 times 16 is 112. So end up with x minus 5 squared over 16. Minus y minus 2 squared over 112 equal to 1. Now, again, positive term is the x squared term. Again, we've got our standard form, so we know our values of h, k, a squared, and b squared looking at it. So here's the value of a squared, right, which is the smaller of the two denominators. So different than ellipse, where the large denominator always denotes a, the positive term denotes a, which means our hyperbola is going to branch out right and left. So you know hyperbola graphs either branch out up and down or right and left. Well, we call this transverse axis horizontal. It's where our center vertices and foci will be contained, is right and left of the center point. So let's go ahead and talk about, again, all the information we need to gather to get to that graph. So again, h and the k values. So we begin to write in that information. We know that our center point of the hyperbola is the ordered pair h and k, which is the ordered pair of 5 and 2. So it's centered at 5, 2. And then our vertices, which we need the value of a to get our vertices. So remember a squared, let's go ahead and find that. A squared equals 16. So that implies a equal 4. So a is equal to 4. Now, since our transverse axis is horizontal, that means we're going to go right and left 4 units from the center to get the vertices. So we're at 5, 2. What's right 4 units of 5, 2? Right, we would add 4, and we get what? We get 9. 9, 2. That's a vertex on this hyperbola. And we go left 4. What's 5 minus 4? 1. 1, 2 is another vertex. There's another vertex. And that gives us the ends, right, which form our branches. Right, branch off from those points. And then the foci, let's go ahead and list those. Now the foci, we need the value of c. So remember our relationship. In an ellipse, c squared equals a squared minus b squared. In a hyperbola, c squared always equals a squared plus b squared. So we end up with 16 plus 112. So we end up with 128, right, with our value of c. So c squared is 128. So to get c, we would take the square root of that. So c is equal to the square root of 128. Now, that does have a perfect square factor. So we could rationalize. That's 64 times 2, right? 128. And we know the square root of 64 is 8. So 8 square roots of 2 is our value of C. So square root of 128 or 8 square roots of 2. And as we look at the foci, we put them a different color. If we go right, again, we're going right and left, right? Because our major or transverse axis is horizontal, right, with this one. So we're going right, left, 8 square roots of 2 units. So right, 8 square roots of 2, we would have the focus at the point of 5 plus 8 square roots of 2, 2. And then if we go left, 8 square roots of 2, we'd have 5 minus 8 square roots of 2, 2. And there are the two foci. There are those two fixed points. So there's our center. There's our vertices and our foci. And if you want to graph it, let's go ahead and show what we found here. Make it a little easier to see our information. I always like to sketch it. So we build in our x and y axis. Right, let's go ahead and plot what we found. So right 5, up 2. Here's the center of these two branches. There's our center point. And 9, 2, so if we go right 4 units, right, we'll be over here at 9, 2. And if we go left 4 units, we'll be over here at 1, 2. There's 1, 2. And you draw in these branches, which slant out. They do have slant asymptotes, which I'm not concerned with you finding, because we can get a quick sketch just using this information. And then our foci, of course, those fixed points inside there. But again, how did we get to those two branches? That was that distance traveled, A being a value of 4, went right 4 units. And then as we travel 8 square roots of 2 units, right, we'll get to our foci. So there's our focus of 5 plus 8 square roots of 2, 2. And over here is our other focus, which is 5 minus 8 square roots of 2, 2. And that's that value of C, right? So there's the value of C here, 8 square roots of 2. Right. We'll write that in over here. So again, C, 8 square roots of 2. So looking at the two branches, there's the hyperbola. So that's a good review of our conic sections. All right, let's move on and finish out our topics. 2 more problems. 23 and 24, we're solving systems of equations, and these equations represent some of our conics that we just finished talking about. Here's a system with 2 variables, right? And one of the equations involve these 2 variables of x and y is a linear equation. Graph a line, y minus 6x equals 0. And the second equation you can see is a equation of ellipse, sum of 2 squared terms where both coefficients are not 1. So can we find a solution? Does this system have a solution? Are there ordered pairs that satisfy both? So graphically, does this line intersect the ellipse? What we'll be looking for graphically. That's the way to check it. Now to solve this one, I'm going to use the substitution method. All right. So the substitution method, it says pick an equation and pick a variable. So I'm going to solve equation 1. All right, I'm going to solve it for y. It's easier the 2 equations to pick. So we'll go ahead and move that 6x over. So that'll give us y equal to 6x. And then we're ready to substitute. So now we've got an expression of x that represents y, and you plug that in. So here's your substitution step in the substitution method. Because our goal, the only way to solve algebraically, is to get down to equation with 1 variable in it, which we're getting ready to do. So with 6x squared, make sure you are plugging into the other equation when you didn't solve for, plus y squared, well, out goes y, and in comes 6x. And now we've got an equation 1 variable, so now we can solve for x. Right? So we got what? 6x squared plus, well, 6x raised to the power 2. That's 6 squared or 36. X squared equal to 42. As we add the 2 x squared terms together, like terms, we get 42 x squared. As we divide out the 42 on both sides, we get x squared equal to 1. Which means what? we got two values of x. So we're looking at our x values. We got plus or minus 1s. We take the square root of both sides. Don't forget, be positive or negative. We're dealing with even roots. So plus or minus 1 for our x values. Now we got to find the other half. We got to go find y. So to find y, we're going to go back up and substitute. This is our back substitution step. And where you go back up? Right back up here to the beginning. So let's start with, for example, x equal to 1. What does y equal? So that implies y equals 6x. So it'll be y equals 6 times 1, which is y equals 6. So there's y. So that implies we have a solution or an intersection point at the ordered pair of 1, 6. So there's one of our solutions. All right. Then we also have the value of negative 1. So x equals negative 1. What does y equal? So that implies y equals 6 times negative 1, which is negative 6. There's y. So that implies negative 1, negative 6 is also a solution. So our solution set, we got two ordered pairs. We got 1, 6, right? And then we got negative 1, negative 6. There are the two ordered pairs for that system. And you check it. You can plug them back in. You can graph them. Quick to check, right? You can put them in there and see they satisfy both equations. Or if you to graph the two, that's where they intersect. And that's review the substitution method. So again, our goal is to get down to one variable. Do that with substitution by picking an equation, picking a variable, and solving for it, and plugging in the other one. Now I'll show you our next method. I'm going to show you the elimination method. So our next problem, we're going to eliminate a variable from the get-go. Elimination method. All right. Eliminate by addition. All right. And to do that, we're going to get opposites. All right. Obtain opposites with x or y. All right. So if you look in this problem, everything is already lined up nicely for us. So we've already got the x squared terms, the y squared terms. We would add them up, right? We get a total of 6x squared minus y squared equal 150. That ain't going to help me, right? I want to eliminate one of the variables, and that doesn't do it. So let's go ahead and make opposites happen. And of course, the easier of the two, right, would be to focus in, to me, on these y terms. So let's eliminate y. Let's make those opposites. So to do that, I'm going to multiply. So go down here. I'm going to multiply equation 2 by 2. 2 times equation 2. So I'm going to leave equation 1 alone. So we still have 2x squared minus 2y squared equal to 50. But equation 2, I'm going to multiply it by 2. So we're going to take 2 times both sides. And as we do that, we end up with what? 2 times 4x squared is 8x squared. 2 times y squared is 2y squared. And 2 times 100 is 200. And now what happens when we add them? We get a total of 10x squared. Y squared is eliminate. And we get 250. So I get 10x squared equal 250. So my resulting equation is an equation of one variable. So now we can go solve for x. So let's go ahead and divide out our coefficient. Divide our 10 out on both sides. Solve for x. So x squared is equal to 25. As we take the square root, remember plus or minus, we get x equal to plus or minus 5. Half what we're leading. Now we got to find the other half. We got to go find y. And this is our back substitution step. We got to go back up to the beginning. Doesn't matter, either equation has this y in it. Let's go plug it back in. So back substitution step, I'm going to plug back in. I'm going to use equation 1. Let's plug it into it. So we got 2x squared. So for example, let's take in equation 1, which is 2x squared minus 2y squared equal to 50. So with x being 5, right? We'll start with it, x equal 5. That implies, what's y equal? That implies 2 times 5 squared minus 2y squared equal 50. And as we simplify down, that's 2 times 25 minus 2y squared equal to 50. And 2 times 25 is 50. 50 minus 2y squared is 50. So we subtract 50 on both sides. We end up getting 0. So negative 2y squared equals 0. Divide out our negative 2 on both sides and solve for y, of course, equals 0. Of course, square root of that is 0. So when x equals 5, y is 0. So that implies, right, we have a ordered pair of 5, 0 as a solution. So that's with x equal to 5. And then what happens, for example, if we plug in what? Our other value. Let's plug in x equal negative 5. What does y equal? So that implies what? 2 times x squared, 2 times negative 5 squared, minus 2y squared equal 50. So that implies 2 times 25 minus 2y squared equal 50, which again is 50. Same thing happening as we had in the previous step. We solve for y, we end up getting negative 2y squared equal to 0. Divide out negative 2. We got y squared equal to 0. And we take the square root, right? We get y equal to 0. So our other solution, that implies we have a ordered pair of negative 5, 0 as a solution. So our solution set, 2 ordered pairs. So we'd a graph, and this is what? A hyperbola ellipse. If you look at the 2 conics that we were given in this system, we've got these 2 points for intersection, 5, 0, and negative 5, 0. You could check it by graphing the ellipse and hyperbola or plugging it in. But that's solving systems. So that's a good review of all our different topics we talked about this semester that we could see on our exam. So I hope this will help you as you're preparing for the final.